Have you ever looked up at the vast, silent expanse of the night sky and felt a profound sense of searching? A feeling that you might be missing some grand, cosmic answer hidden just beyond your reach? Before we dive deeper, subscribe now if you enjoy this kind of thinking. If the night sky has ever felt like a locked door, what if I told you that the Milky Way is not the room we're trapped inside, but the breathtaking view created by exactly where we stand? The reason it once seemed an unsolvable mystery is the very same reason it now reveals its secrets to us. It's all a matter of perspective. To understand this, imagine you are standing in the middle of an immense, ancient forest. But this isn't a forest of trees, it's a forest of stars, hundreds of billions of them, arranged not in a sphere around you, but in a vast, flat disk, like a cosmic frisbee. Our solar system, our Earth, our very existence is nestled deep within this structure. We are not looking at the Milky Way from the outside. We are living inside of it, about 2/3 of the way from its glittering, chaotic center. Now, from our vantage point within this stellar forest, when we look out in any direction parallel to the ground, or in this case, along the plane of the galactic disk, our line of sight passes through an incredible density of stars. We are peering through the thickest, most crowded part of the forest. The light from countless distant, unresolved stars, each too faint to be seen individually, blends together. Their combined, overlapping glow creates that luminous, hazy river of light we call the Milky Way. It's not an object hanging in the distance, it is the structure of our own home galaxy, revealed. Conversely, when we look up or down, away from this plane, our gaze passes through a much thinner section of the disk. The sky appears darker, emptier, simply because there are far fewer stars along that line of sight. But the stars aren't the only thing shaping our view. The space between them is not empty. It's filled with colossal clouds of interstellar dust and gas. These are the raw materials for future stars and planets, but they also act as a cosmic fog. This dust is incredibly effective at absorbing and scattering visible light, a phenomenon astronomers call extinction. It creates the dark, intricate rifts and lanes that seem to be carved out of the Milky Way's bright band, obscuring the even greater number of stars that lie behind them. This dust also scatters blue light more effectively than red light, causing the starlight that does pass through to appear warmer and redder, a process known as reddening. This is why what we see with our eyes is only a fraction of the story. To pierce this veil of dust, we must look at the universe in different kinds of light. In the infrared spectrum, for instance, the dust that blocks our view in visible light begins to glow with its own heat, and the light from stars behind it can pass through more easily. Suddenly, the dark rifts vanish, revealing a torrent of stars previously hidden. In radio waves, we can map the cold, dense hydrogen gas that traces the galaxy's grand spiral structure. And in high-energy X-rays, we can witness the violent, superheated regions around black holes and neutron stars. Each wavelength gives us a new layer of information, a new piece of the puzzle. By combining these multi-wavelength views with clever observational techniques, we can begin to map our galaxy from the inside out. We measure the distances to millions of stars using parallax, the slight shift in their apparent position as Earth orbits the Sun. We identify special types of stars, like Cepheid variables, which act as standard candles, their predictable brightness allowing us to calculate their distance with astonishing accuracy. Missions like the Gaia Space Observatory have measured the precise positions and motions of over 1 billion stars, creating an unprecedented 3D map that reveals the galaxy's majestic spiral arms, its central bar of old, yellow stars, and the dense, spherical bulge at its core. Even with our own eyes, we are limited by time. The human eye and brain process light in real time, capturing only a fleeting snapshot. We can't accumulate light over minutes or hours, but a camera can. Through long exposure photography, a camera's sensor can patiently gather photons from the faintest, most distant objects. Light from tiny, dim points is stacked, pixel by pixel, until the faint glow of a nebula or the subtle colors in a star-forming region emerge from the darkness. This is how astrophotographers reveal the breathtaking structure and vibrant color that our eyes can only ever hint at. They are simply letting time do the work, collecting the ancient light that has traveled for millennia to reach us. Our perspective also creates beautiful illusions. The Milky Way often appears as a magnificent arch stretching across the entire sky because we are looking at a flat plane from a point within it, just as the equator, if you could see it, would wrap around your horizon. Its position and tilt change with the seasons as our planet journeys around the sun, offering different slices of the galactic view throughout the year. And its visibility is a fragile gift, easily washed out by the glow of light pollution from our cities, which reminds us that the darkness of the night sky is a precious natural resource. So you see, being inside the Milky Way doesn't stop us from understanding it. It is the very thing that creates the magnificent spectacle we witness. The initial mystery of that glowing band dissolves not by escaping our position, but by embracing it, realizing that the view from our cosmic home is a breathtaking and beautiful consequence of geometry, dust, light, and time. We'll explore more of our galaxy's secrets in a moment, so be sure to subscribe and hit the notification bell to join us on this journey.
If this made you think, there's more waiting for you. Subscribe and drift into deeper thoughts.